What's up? What's up? It's your man, Jimmy Chan. All right, so we're talking about the addition rule and complements. All right, so if something is mutually exclusive, that means they are disjoint. Two events are, two events are mutually exclusive if they have no outcomes in common. So if we look at the Venn diagram, guys, what we would see is that I can't draw a box. That's what we can see. Now, what we can see is that, literally, I can't draw a box. What we can see is that the two events, let's say this is called event E, and this over here is event F, right? They have nothing in common at all, right? They're disjointed, right? Unjointed or not jointed, okay? So that's what mutually exclusive means. And if that's the case, then that means we can go with this formula. Again, the key point here is the or. Or should I do this in red? Really put together the importance of or right here, right? So the important part is or. And you see that that is going to be with that, with the plus sign, okay? So that is the case there if it's mutually exclusive. So in other words, if they don't have any outcomes in common, then this is the formula that you would use. However, what if they did? Well, then it wouldn't be mutually exclusive. That's number one. Number two, that means that they do have things in common. So that means if this is if this is event E, and this is event F, okay, that means what we have right here would be event E and event F. Okay, so that is where the common thing is. So two events are not mutually exclusive if they have outcomes in common, which this one right here has outcomes in common. So in that case, if there is outcomes in common, we have to take the two probabilities, add them together, and then subtract away what is in common. All right. Again, because this is an or. There's one or the other. All right. So if I take this event, let me do it this way. If I took this event E, and I took this event here, what I actually did was that I would have counted this yellow shaded area twice, once with the red, then once with the blue. So that's why we take one of them away so that we're not counting it twice. All right. All right. So here's an example. So let's say we're given a table here, right? Never married, married, widowed, divorced, separated, males and females. One of the things that you may want to do is right off the bat, before you even read the problem, is get the totals. How many total males are listed here? How many total females are listed here? How many total never married are listed here, or married listed here, or so on and so forth, right? And then what is the ultimate total? Because the number of males plus the number of females should give me this total. And the number of all of these totals should also give me this total. So it also make sure that my math is correct. All right. So with that being said, is determine the probability that a randomly selected U.S. resident is widowed or divorced. Okay. Widowed or divorced. Okay. So let's look at A. So I want to find the probability of widowed or divorced. So that means I gotta find, now, is widowed and divorced have anything in common? No. So this is gonna be mutually exclusive. Okay? Because they don't have anything in common. So I'm going to find the probability of the widowed and add it to the probability of the divorced. Okay, so what's the probability of widowed? Well, widowed is here. There's 15.2 out of 260. 0.1 plus the probability of divorced is 28.2 divided by 260.1. So that is going to get me a 0.167 as a probability. Where part B, it says determine the probability that a randomly selected U.S. resident is male or widowed. Well, is there anywhere that male and widowed are in common? And they are. They're very much so in common, right? So in this case, this is not mutually exclusive. Okay. So if that's the case, then when I'm looking for the probability of male or widowed, then I'm looking for the probability of male plus the probability of widowed minus the probability of male and widowed. Okay, so let's take a look at what I'm looking at. So probably a male would be right here. Oops. Let's use a different color so you guys can follow. So it's going to be, so it's going to be, actually, I didn't want to use that. Let's do this. Here's a probability of male. Probability of widowed would be here. And then probability of male and widowed will be here. Okay, so there's my three numbers there. So male is 126.1 over 260.1 plus the probability of widowed is 15.2 over 260.1 and minus the probability of being male and widowed 3.3 over 260.1. And that should give me about 0.543, right? So that should be your probability. All right. Oh, wait a minute. That is actually not what you get because that one did not subtract it. So let me go ahead and clear that up here really quick. That should not be what you get. Let me see here. So this one you should get 141.3 over 260.1 minus 3.3 over 260.1. So that's going to give you a much smaller number. So that means I need to figure that out. $141.3 minus 3.3. Divide that by 260.1. So it's going to be 0.531. And there it is. All right. And then let's continue on. But again, notice that it's not mutually exclusive because I can actually find where it's male and widowed. All right. Where the first one with widowed and divorce, I can't find anywhere that I can draw out a number for that together. Complement rule. Okay. So the complement is just going to be 1 minus whatever the probability is. In other words, subtract it from 100%. So over here it says, according to the National Gambling Impact Study Commission, 52% of Americans have played the state lotteries. What is the probability that a randomly selected American has not? All right, so the keyword is not. All right, so if the keyword is not, that means I want the complement. So I want the probability of not played. So that's going to be 1 minus the probability of played. Well, 1 minus the probability of it played would be 0.52, right? Because 52% have played. So therefore, it's going to equal to 0.48 would be the probability of played bill not played. And that's what the complement would be. All right. I hope this helps. If there's any questions, please let me know. See ya. Bye.